All right, we are continuing the question that says a $1,000 investment earns 2% per year, compounded annually over 5 years. And the question that we're interested in answering is it better to double the interest rate or double the time invested? So we just finished in the previous video doubling the interest rate, and now we're going to take a look at what happens if we double the number of years that we're investing for. So this question is a compound interest question. So I am going to use the compound interest formula, which is A equals P times 1 plus I to the power of N. I'm going to list my variables down the side. I'm going to leave a little extra line for I because it requires some work. Okay, so when we look at the question again, that $1,000 is our starting amount or our principal. So that's P. So P is $1,000. Now it says our interest rate is 2% per year. Now in the previous one where we doubled the interest rate, we multiplied that by 2 to use 4%. But this time we're interested in doubling the time, so we're going to leave it as 2%. So I'm going to write 2, but I have to divide it by 100. So 2 divided by 100 is 0.02. Okay, and the last thing in my question is that we are investing for 5 years. That is the N, but I will remind you that we are looking at what happens when we double the number of years invested. So we're not going to invest for 5 years. We're going to do double that, or times 2, and do 10 years. So my N value is 10. And then A is what we're trying to solve for, the final value. So I'm going to take all of those numbers, substitute them into the equation, and see what we get. So I have A equals, P is 1,000 times 1 plus I is 0.02. That's to the power of N, which is 10. Order of operations says we should do our brackets first. That's the B part of BEDMAS. So I have 1,000 times, I'm going to add 1 and 0.02 to get 1.02. And that is still to the power of 10. Now, order of operations says we should do the power first. So I have 1.02 to the power of 10. But I don't want to have to write that whole decimal down, so I'm just going to go ahead and multiply by 1,000. And I get $1,218. And now it looks like 99 cents, but I am going to take a peek at that next number. It's a 4. As long as it's under 5, we're good to go. So that's going to be 99 cents. So if we double the time invested, we should have $1,218.99. Now, in the last part of the video, we'll take a look at the question, is it better to double the interest rate or double the time invested?